Assalamualaikum, my dear students. I hope all of you are fine and doing well. So in our today's lesson, we will discuss about the Avogadro's law. Basically, Avogadro's law, it is related to the volume of the gas and to the number of moles of the gas. So the definition for Avogadro's law here we have when the number of moles of the gas is doubles. It's mean when moles of the any gas increases at constant temperature and pressure, the volume of the gas also increases or it also get doubled. So this is the main we have Avogadro's law. Another definition for the Avogadro's law we have when we have equal mole volume of all the ideal gases. When we have equal volume of all the ideal gases at constant temperature and pressure, then it contain equal number of molecules. It contain equal number of molecules. This is a simple about Avogadro's law. So the volume of the gas is basically directly proportional to the number of moles. So volume is directly proportional to the number of moles. So here we just gain the relationship between volume and number of moles. But the condition for this we have to keep the temperature and pressure as a constant value. So here we have the Avogadro's law which can be written as volume V1 over the number of moles of the gas 1 is equal to the volume of the gas V2 divided by the number of moles of the gas number 2. Or we can also write it as V1 into N2 or by cross multiplication V2 into N1, where N is denoting the number of moles and V is denoting the volume of the gas. So the simple how we can denote it with the graphical representation. Here we have the amount of moles along x-axis and the volume along we have it is y-axis. So when we just have a graph between we gain the straight line because as the number of moles of the gas increases, the volume of the gas also increases. There is a direct relation between both these values. Next we have an example. For example, in the container 1, we have the quantity of the gas in mole which is N1. So here you can see that we have less molecules and the volume of the gas is also less. But on the other hand, when we take the second container and the quantity in moles of the gas increases, then the volume of the gas also increases. So the number of moles is directly proportional to the volume of the gas. When we increase the number of moles, in turn, the volume of the gas also increases. This is the same to like that or indirectly it is related to the statement we have the general gas constant in which we were taking 1 mole of ideal gas at temperature and pressure it occupies the volume which is 22.414 dm cube. So likewise if we have 1 mole of gas, if we have 1 mole of gas, then the number of molecules it is containing it is Avogadro's law which is 6.02 into 10 raised power 23 molecules of the gas will be present in it. So this is a simple example of the Avogadro's law. Likewise, another example for this, if we have 1 dm cube of different gases, if we have 1 dm cube of different gases in the container and the gases here we have hydrogen, helium, nitrogen, oxygen and carbon monoxide. They are in the separate vessels. Then at standard temperature and pressure the number of molecules that these gases will contain it will be equal to 2.68 into 10 raised power 22. So the number of molecules will be same of all these gases as the masses of the gases are different. On the other hand, when we have all these values, we can get it by dividing 6.02 into 10 raised power 23 with the volume which is 22.414 dm cube. So the answer is there. Similarly, when the temperature and pressure both are equally changes for these four gases, then the new volume that we gain, it is same 1 dm cube, and the number of molecules will be same, that is 2.68 into 10 raised power 22. So this is a simple explanation about the Avogadro's law. When we are going to increase the number of moles, the molecules of the gases also increases. Next, we have the graphical representation for the number of moles of the gases. So we just take moles along x-axis and the volume along y-axis. So we just gain a straight line. It's mean the volume is directly proportional to the number of moles of the gas, where the proportionality constant here we have, it is a constant, and there is a direct relation between both volume and number of moles. So volume is directly proportional to the number of moles. Volume is equal to constant into n, and ratio of volume to number of moles, it always remains constant, and here we have to keep temperature and pressure as constant value. Likewise, if we will discuss about the simple example, if we have 1 dm cube of hydrogen at STP or standard temperature and pressure, so its weight is approximately 0.089 grams. And if we have 1 dm cube of oxygen at STP, then its weight is almost 1.4384 grams. But the number of molecules in both these, it is same. So the answer or the result that we gain, it is the volume increases when the number of moles increases, irrespective of the mass of the gas. It does not depends upon the mass of the gas. It means the molecules does not depends upon the mass of gas, rather than it depends upon the number of moles of the gas. If the number of moles of the gas increases, in turn the molecules of the gas also increases, because there is a direct relation between volume and the number of moles of the gases. So this is all about today's lecture. I hope you guys understand, and if you have any queries you may ask me about that, and I will get back to you guys soon. In the next topic, we will discuss about the Dalton's law of partial pressure. For that time, you guys have a good day and keep learning.